So in the previous tutorial, we went over conjugate acids and bases. In this case, I just want to go over being able to determine the strengths of an acid and base, and from those strengths, be able to figure out what direction a reaction is going to go in. Is it going to shift to the left, or is it going to shift to the right? Because of the fact that these type of reactions can reach equilibrium. So you do have those two reactions taking place. So let's just go over first what strengths of acids and bases are. It's just basically how well the acid or base can break up in water. So if you were to put an acid or a base in water, how well is it going to ionize? And this is also known as how well of an electrolyte something is. If it's a strong electrolyte, that means it easily breaks up in water. If it's a weak electrolyte, that means it doesn't break up well in water. Just basically the higher the strength, the stronger the electrolyte's going to be. So the more H plus or H minus you'll get within that particular reaction. Right here is just the table of strengths of acids and bases. As you can probably see, there aren't any values. But what you'll look at is just basically the position of an acid on this particular table. The higher up you go, the stronger the acid is. And it's the complete opposite on the other side, where the strongest bases are down here, the weakest bases are up there. So you will need to use this for the following types of examples. So in this case, you want to figure out what direction this particular equation is going in, and basically you're trying to figure out which one of these is stronger. Whichever one is stronger, that is going to ionize, so it's going to go in the opposite direction of it. So for example, in this case, what you need to do first is figure out which acids you have. So again, anything that has an H in front of it would be an acid. So you have HCN and you have HSO4 minus. So those are the two that you're going to try to define on this particular table. So you have HCN, which if you look here, HCN is down below. HSO4 minus is up here. So the HSO4 minus is going to be stronger, so that means it's going to go, this particular equation is going to shift to the left. So basically it's going to be going that way, because the HSO4 minus is stronger, and so it's going to completely ionize. So it's going to go in to the left to be able to do that. Here's another example where, again, first thing you want to do is figure out which ones are acids. Now you might see that on this side you have H2S, on that side you have HS minus. Which one would be the acid? Well, in this case it's going to be the H2S, because of the fact that that's the one that has that extra H on it. So that's your acid. So here's your acid here, and then here's your other acid. So figure out those on your table. So you have H2S here, you have HC2, H3O2 there. HC2, H3O2 is going to be stronger, so that means this equation also is going to shift to the left, because of the fact that the HC2, H3O2 is going to completely ionize, and so it's going to break down to the C2H3O2 minus. Now there are other ways of figuring out acid strength, and this is by looking at the molecular structure itself of the compounds that you're given. And there are three types of criteria that you can follow along with to be able to figure this out. One of them is just basically looking at the periodic table and comparing the acid strengths within, on the periodic table, where the stronger acids will be the ones that are lower on the group, and also the ones to the right on the periodic table. So the ones down at the bottom right will be the strongest acids, whereas the ones to the top left will be the weakest acids. Another criteria is just basically the acid that has more oxygens in it, that will be stronger. So you might notice that you have everything else of the structures exactly the same except for the number of oxygens. So at that point you'll just look at the one that's higher in oxygens to be able to figure out which one's stronger. And then the last one is just basically the acid that has a more positive charge will be stronger, because of the fact that it has more hydrogens attached to it. So here are a couple of examples of this, of the three criteria that I just talked about. You have HI and you have H2TI, TE, sorry. So you're looking at the I, you're looking at the TE. Look at the periodic table, which this might be a little difficult to see, but you know, there's your TE right there, there's your I right there. Whichever one is closest to the right is going to be stronger. So in this case, between the two, HI is going to be stronger because it's more to the right on the periodic table. For the next one, you have HSO3 and you have H2SO4. There are two things that you can look at here to be able to figure out stronger. You can either look at the number of oxygens, which in this case, this one has more oxygens, so it would be stronger. Or you could look at, you know, which one's more positive, which, you know, that one has a negative charge, that one doesn't, you know, so this one is more positive. So with both of those criteria, you can see that H2SO4 is going to be the stronger acid in this case. For the third one, everything else is exactly the same except for the number of oxygens. You have 4 in this case, you have 3 in this case. So basically it's going to be the one that has more oxygens, so it's this one that's the stronger between the two of them. And then for this last one, again, there are two different ways you can look at this. You can either compare the S and the SE, or you can look at the charge, which you have negative on that one, you don't have one on there. You know, so in this case, this would be stronger because it's more positive, and if you were to look at S and SE on the periodic table, S is right there, SE is right there. So SE is lower down on the periodic table, so it would be stronger.